Hey everyone, and welcome back to another 3D revolution. PrusaSlicer is one of, if not the best slicers available at the moment, and unlike others like Simplify 3D, it's completely free. Also surprisingly, considering the name, PrusaSlicer isn't just for use with Prusa printers, but can work with pretty much any FDM printer. For this video, I'm going to be taking you through the basics of PrusaSlicer, all the way from getting it set up and calibrated on your computer, to exporting your first G-code ready to print. So let's take a look. The first time you launch PrusaSlicer after installing it, it will have likely opened the configuration wizard. If it hasn't and it just looks like this, pop up to configuration and select configuration wizard. This is a nice simple tool which helps get PrusaSlicer set up for whichever printers you're going to be using it with, so let's click next and get started. This is where you can select any Prusa made printers you're going to be using with the software. If you're not going to be using Prusa printers, don't worry, just click next and continue, but if you are, select whichever printer you're using as well as the nozzle size for each printer. I'm going to select the standard 0.4mm nozzle on the Mark III S Plus and click next. This page is exactly the same, but it is for Prusa made SLA printers. If you're going to use them, select it and click next. Now here we get to select printers made by other companies. If you want to select a printer that is made by any of the companies listed here, select the company, let's say for example Creality, and then it will add another tab to the left. So you can see there it's got Creality FFF. If we go ahead and click next, we'll go down to that Creality tab and we'll get given a range of different printers made by Creality to choose to add to PrusaSlicer. We won't be doing that for now because any printer we add here is going to be the same process repeated down the line. This is the last area in the configuration wizard where you can add a new printer to PrusaSlicer. Here you can add any printer not made by Prusa or one of the printers listed in the other vendors section. So select define a custom printer profile, give it a new name, and then click next to select things like the board type, the software type, and things like the bed size for the printer. This will obviously all depend on which printer you're adding, so I won't be adding one now, but that's how you would add a custom printer profile. Here you're able to download the presets for things like the temperature and speed for different filaments you're likely to use regularly with PrusaSlicer. So go through and select whichever filaments you're likely to use regularly, but remember you can always just change the specific settings anytime you change your filament. Here's a section which allows us to automatically update both the software and the presets that we've downloaded and installed. I'll leave both of these ticked, but if you're worried about a new update coming out with issues you're not aware of, you can always update in the future by just going to Help and then selecting Update from there. So let's click Next. This feature allows you to automatically re-import models and therefore update changes to anything in 3MF and AMF files when you open them. I'll be leaving this unticked for now, but we'll be looking at this in more detail on a later video. By selecting these two tabs here, it now means that when I come across a 3MF file or an STL file on my computer and double click it, it will automatically open in PrusaSlicer rather than asking me which software I want to use to open it. PrusaSlicer has its features divided into three different modes: Simple, Advanced and Expert. Because this is the basic tutorial, we'll be just sticking to the simple mode for now, but you can always switch between the different modes by the links at the top right of the screen. All this basically does is just hides the features that are either too advanced or unnecessary for those that are just getting used to using PrusaSlicer. I'd also suggest if you're regularly importing models that use inches as their dimensions, select the tab here, and then let's click Finish. Okay, so with the configuration wizard done, we've now got your printers and filament presets all installed into PrusaSlicer ready to go with your setup. So let's take a look at the PrusaSlicer user interface. This thing in the middle here represents your build plate, so you can rotate around that using the standard left click and drag. You can also move around it using the middle click or right click and drag, and you can zoom in and out using the middle wheel scroll on your mouse. So to get us started on the rest of PrusaSlicer, let's import a model by selecting the Add button here. Let's select the Kali Dragon, which is the modern version of the 3D Benchy, and is basically a model designed to stress test your printer to help you refine your settings. So with that model selected, if I was to click and drag it around the build plate, it would allow me to reposition it. If I was to then go up to the Add button again and add another model, let's add the 3D Benchy, the original one, and click Open, you can see that they're now overlaying each other. If I was to print this as it is now, they would be merged and they would be printed as a single model in the form that they are now. A quick and easy fix, however, is to go up to that top bar again and click this button here, which will automatically reposition everything on the bed so it's not overlapping each other. This will work with 2 models or 30, anything that's in the build space that will evenly distribute them. If we select and delete the original benchy now and click the same button again, it will center any object left on the bed. Whilst you can remove items you've got selected by hitting the delete key, if you go up and select delete all or press Ctrl delete, you'll delete everything on your build plate. Okay, let's take a look at the edit tools. If you click and select your model, on the left here will be a range of different edit tools. The first one is move. Unlike clicking and dragging your model around the build plate, this allows you to select specific axes, including the Z axis, though by default that's always going to snap back down to the build plate. You can always recenter it by hitting A on your keyboard or using the arrange tool. The next edit tool is scale, and much in the same way allows you to edit individual axes. As well as editing axes individually, you can scale the entire thing uniformly by selecting and dragging the orange square cubes. The next edit tool, much the same again, is for rotation, and again allows you to rotate based on different rotational axes. If the rotation causes it to go into the bed at all, when you let go of that axis it will spring up, so it's always going to be sat on top of the bed at the angle you've selected. With all 3 of the position, scale and rotate tools, you can also edit them on the right here by entering the exact figure that you need and hitting enter. The next edit tool is a really useful one. The place on face tool allows you to automatically reposition the model so the face you've selected is flat against the print bed. With a model like this, you obviously always want it standing up on the base, but for example with something like my zip toggle model, you may prefer to print with it either on the thinner side or the wider side, and this makes that really easy to flip between. The final edit tool in simple mode is the cut tool, which is really useful if you're trying to print a model which is too tall for your workspace. With your model selected, just click cut and then select the height you would like to divide your model up. When you've found the height that you want, just click Perform Cut, and that will separate your model into 2 separate models at that point. You can then click A or the Arrange tool, and it will separate them into different models on your print bed that will then fit within your print space. You can see here I've chosen a bad height because it's separated a small chunk of the bottom model, but you can always undo that and then select a different height. There are more advanced edit tools available, but these are all that need covering for the basic tutorial. If you'd like to learn more about the advanced ones, head over to my PrusaSlicer Advanced Features tutorials. But for now, in this basics tutorial, we're going to move on to print settings. We've now looked at both the edit tools and the navigation area in the user interface for PrusaSlicer, and we're going to move on to the print settings up here. You can quickly and easily skip to the settings or go to the presets on the right hand side here, but for ease of navigation we'll use the tab at the top. The first option under print settings is your layer height. This is how far the extruder will move up on the Z axis per layer, and therefore how much it needs to extrude per layer. The smaller the layer, the higher the resolution of your final item, but the longer it will take to print. 0.2mm is a fairly standard layer height. I often switch to 0.1mm for more detailed prints, and go up to 0.25mm for more functional prints that I just need quickly. The first layer height is the same feature but only referencing the very first layer. It can be good to have a slightly thicker first layer to improve adhesion and alleviate any issues caused by slight bed imperfections. I usually leave this just at 0.2mm. Your perimeters are the amount of outer layers it will create for your model. With 3D printing, most of the interior of your model will be infill, which we'll be looking at more later, but this is effectively how many perimeters your model will have. Imagine the shell of an egg in the shape of your model. 2 to 3 is usually a good number to have here. Spiral vase is a feature for printing items with no infill and just a single perimeter line. It can be considerably faster and uses much less filament, but is very weak and won't work with a lot of designs. Similar to the perimeters, the solid top and bottom layer figures here denote how many layers at the top and bottom of your print are completely solid. The minimum shell thickness is more of a safety measure to ensure that your top and bottom layers never get too thin. Because your solid layers function is based on number of layers, and because you can change the thickness of your layers, this means that if you were printing in a high resolution setting, you could end up with really thin horizontal shells, so entering a minimum thickness here ensures that regardless of your layer height, your horizontal shells are always suitably thick. The seam is the point where the nozzle moves up to the next layer. this can create a slight line or a seam on the exterior of your model. So there are options here to alleviate that effect by changing where the seam takes place. You can set it to aligned so it always does them in the same place, keeping a neat straight line. Randomized, so at the worst you get some random small dots. Nearest, which is nearest to where it finishes the layer, which is likely similar to aligned. Or you can set it to rear, where it will place it at the back of the model. Finally in this section we have fuzzy skin, which is an experimental feature by Prusa, which lays down the outer perimeter to give a textured fuzzy effect. The next section of print settings we're going to look at is Infill on the list on the left here. Infill is how 3D printing creates strong structures without everything needing to be solid plastic the whole way through. It works similarly to a bird's bones, which allows them to be lightweight and strong. The density is simply the percentage you want the infill to be, where 0% would make your model completely hollow and 100% would be completely solid. For most prints, 15 to 25% is perfect, but where items need to be particularly strong, you may need to use a higher infill. You can even have different infill settings for different parts of your print. Check out my advanced PrusaSlicer features video for more on that. Fill pattern is the shape the infill will be. Gyroid is one of the newer options. It was actually developed for 3D printing metal brake pads, allowing both strength and good heat dissipation. But it's really effective for standard FDM printing too. For items that have particularly small or thin areas, rectilinear may be a better option. The top and bottom fill patterns are, as the name suggests, just the fill pattern used for the top and bottom layers of the print. And whilst generally these are left on monotonic, you can experiment with other patterns here, primarily for aesthetic differences. We now move on to the next print settings section, skirt and brim. Skirt and brim are both effectively the same thing, a single layer perimeter around the model's base. Skirt is often used to mark out the perimeter of your model before it begins, and also helps ensure a steady flow of filament has been achieved before printing. With simple setting turned on, the only setting you can get here for skirt is what distance you'd like between the object and the inside of your skirt, often just left to 2mm. A brim is pretty much the same thing, but is physically attached to your model, again just from the bottom layer. This can help with adhesion and stability on thin models, and can help prevent curling on the edges of your print when printing in materials such as ABS that are more susceptible to exterior temperatures. The settings here are for where you'd like your brim positioned and how thick you'd like it to be. I generally don't need to use brims, so I leave this set to 0, which turns it off. And the final section we've got in the print settings area is support material. Support material is the scaffolding of the 3D printing world. In short, it's a temporary structure printed to provide a solid base for heavy overhangs of your model higher up that would otherwise be printing in thin air. The support material, when printed successfully, should just pull away from your model, or at the very least snap away. Or if your printer has multiple extruders, when you move on to the advanced features, you'll be able to print your support out of a soluble material such as PVA and then dissolve them in water after you've printed. The two main options you have here determine when and where to create support material. The first one, generate support material, turns it on and off in general. With this unticked, even if you've used advanced tools to apply support material, it will be ignored when slicing your model. The second of these two options is auto-generate supports, which, if ticked, will automatically design and generate support material for any part of your model that it thinks could be useful. Remember, this will only work if generate support material is ticked as well. The final support material setting in simple mode is support on build plate only. As you saw a second ago, without this ticked, support material will be generated under any overhangs. That includes starting the support material on top of the model. Whilst sometimes this is unavoidable, even once removed, support material printed directly onto your model can leave marks, bumps and scars, and so is best avoided wherever possible. So to avoid this, just tick the support and build plate only box, and it will then only generate support material where it's able to start directly on the build plate like this. That's it for print settings. The next settings menu is filament settings. At the top here is a drop down list of any presets you've already saved for filaments you regularly use. Moving on to the settings, unless you fitted an MMU or are using a multi-extruder printer, you don't need to change the colour and this can be left alone. Equally, the diameter of your filament will be determined by the printer you have, and that won't change between different reels of filament. Most FDM printers these days use 1.75mm filament. It's worth noting, however, that if you get filament from a supplier that you're not familiar with, they can occasionally produce filament that is not the exact diameter you requested, so 1.75mm filament, for example, could be more along the lines of 1.65mm for a lot of its length. If you've got a pair of calipers, try measuring the filament at a few different points and see what its diameter is, which you can then update here. This will affect the amount of filament extruded and can help with over or under extrusion. The density, cost and spool weight of the filament is not necessary for slicing, but is used for the price estimate when you've sliced a model to let you know how much the print will cost you. More importantly in this section is the temperature area. This will largely depend on what type of filament you have, whether it be PLA or PETG, etc., but also on the manufacturers, as a PLA from one company may have a different melting point to a PLA from another company, so check the packaging or manufacturer website for their recommendations. For the nozzle temperature, there are separate options for the first layer and the rest of the print. It's generally advised to print the first layer slightly warmer, as this will help with adhesion to the bed, so I generally use +5 degrees for the first layer. The bed temperature has the same division of settings, but I generally keep it the same. Again, the optimum temperature depends on the material you're printing, but where suitable, I usually use 50 or 60 degrees for the entire print. Again, cooling requirements will depend on the material you're using. Usually you want maximum cooling, so keep both of these boxes ticked. However, if you're printing with a material that explicitly requires zero cooling, you'll want to untick both of these, or move to the advanced or expert modes for more options. For the most part, this section can be left alone. Both settings available here in simple mode are referencing retraction, which is when the printer pulls the filament back into the extruder temporarily when it's stopping extruding due to moving to a different location or changing layer height. The length option allows you to specify how much filament will be retracted when retraction happens. The Lift Z option allows you to specify how high the extruder lifts during retraction. Generally these can be left unchecked, which will allow PrusaSlicer to determine the values based on your settings in the printer settings menu. However, if you wanted to set different settings for a specific material, or if you're having issues with stringing or blobbing, making tweaks here can help with the results. For more information on this, keep an eye out for my video on troubleshooting with PrusaSlicer. The final settings mode we have is printer settings. In simple mode, you only get a few options here, and generally, unless you're switching to using a different printer, you don't need to change anything here. All the options you can edit in simple mode are under the extruder tab. In here, you can change the nozzle diameter, and you also have the default retraction settings, which are overwritten if you're using a filament preset that has the override section filled out like we just looked at. And the final setting here is extruder color, which allows the preview in PrusaSlicer to have a different color for areas printed by different extruders if your printer has more than one. Otherwise, you can leave this as default. Okay, so time to slice this model and see how it'll come out. Let's start by going back to the platter and clicking Slice Now in the bottom right. Once it's finished slicing, PrusaSlicer will display your model as it will be printed. You can have a look down and inside your print using a few controls. The first is by layer control. Click the arrow at the top here and drag it down. This will allow you to see inside your print at different layer heights. You can do the same from the bottom layer too. The other main tool here allows you to watch the actual motion of the toolpath of the layer you're currently on. If we lower it down to partway down the model and then click and drag from here, you'll be able to watch the layer as it will be printed, and on the left hand side you'll get a list of the G-code commands the printer will be receiving. In the bottom right, you now get a rundown of your print, including the amount of filament it expects to use, both in length and weight, the cost, if you've entered the details into the filament settings, and the estimated time for printing. At the top right, you can quickly switch between some of your settings, including supports, infill percentage, and between different print and filament defaults that you've got saved. Finally, we can look at the different view modes you have for your sliced print. Down here, it's currently set to feature type, and highlights the different types of printing in different colours up here. So you can see, for example, the exterior perimeter is bright orange and the internal infill is solid red. There are other view types as well. Instead of the features type, you could highlight something like the height of the layer or the speed that an area is printed. And if we select that, we can now see the speed that each area of our print is printed at. And finally, it's time to export. To export your G-code, simply hit the Export G-code button on the bottom right. If you've got the printer's SD card connected to your computer, you can save a couple of seconds by hitting this button, which will default the save location onto that card. And you can then eject that SD card from your computer just by hitting the button here. Well, I hope that's helped you get a better understanding for the basic features of PrusaSlicer. If you feel you're ready to progress beyond the simple mode of PrusaSlicer, don't forget to check out my videos in my new series, The Advanced Features of PrusaSlicer, which I'll be uploading very soon. Otherwise, don't forget to like and subscribe, and I'll see you guys very soon. Cheers.